All right, so as I've promised, I have a question on 1 in 60 here. Now, this question is not a very DGCA friendly kind of a question. You don't get to see this kind of 1 in 60 questions right here, but this is one of those questions which I got when I was trained in a ground school, basically, right? So, but very, very interesting questions. I do really pop up this question to my students in the class, even though, as I said, it's not really part of your understanding requirement. All right, so you can see a figure here, and you can see the blue line and the red line. It's basically the blue line is the planned track of the aircraft, and the red line is the actual track flown by the aircraft, which is more like track made good. All right. The question is, find the heading alteration required at B to track to destination C. All right, very interesting question. I wanted to pause this video immediately, take a paper, draw the diagram, and trying to find out the heading change that is required at B to track to destination C. Straight away. So heart's burning. I know it's not that difficult, but you know, the first spark is needed, and once you get that, any of these kind of questions can be solved just like that. Right, perfect. So here, an aircraft is traveling. Let's kind of understand this question. Aircraft is supposed to travel. The planned track of the aircraft is along this blue line all the way from this point up to C. Right? Now, the distance from the point over here, let me kind of mark this point to make it much more easier, 0.1. Right? So distance from 0.1 all the way to this particular intersection point here, which I'll mark as 0.2. So from 1 to 2 is given as 70 nautical miles here. Right? And the distance from 2 to C is given as 40 nautical miles. So those distances are along the planned track. But as we know that we don't really get to fly planned track that often, we get drifted, and the aircraft kind of drifted off, and now the journey starts from A over here. So we don't really bother about the journey before that. So our concern really starts from point A. It actually travels all the way, intercepts the track, but kind of drifts off to the left now, and reaches point B, and all of a sudden the pilot realizes like, oh, I'm not on track. So usually we have multiple ways of doing that, especially if you're flying general aviation, not very common in India. But if you're flying outside the country where GA is kind of just thriving and you kind of do the actual navigation using maps, you tend to pick up significant geographical features over which you're supposed to fly. Right? It could be a stadium, it could be a large lake, it could be a building, something that you can significantly see and identify on the chart from that particular height. And you must have marked something of that sort. Say, for example, somewhere around here, you might be expecting a lake, which is quite big. So I'm expecting a lake to see a lake somewhere around here. Yep. But when I reached point B right here, I realized that, oh, the lake is towards my right, which means I've drifted off to the left. And now, what heading am I supposed to fly, or what heading change am I supposed to make at this point B if I want to track towards my destination, my original destination, which is C? That is what you're asked to find out. All right, so as I said, you must have gone through diagrams, I believe, and it's quite an interesting question, isn't it? Right? And I have seen students really getting kind of freaked out by the way the picture is actually put. I have some different, even more weirder pictures coming up after this question, so stay tuned. Let's see how we can find this particular heading change. So let's see what we need initially. So for that, let me kind of grab this question and put a little underneath here. I need some space above. All right, now you can see here that the aircraft, we are kind of flying all the way along this red track made good, and if you don't do anything about it at point B, if you don't realize it, you keep drifting away, right? And this would have been our track. Basically, we are asked to find out what heading change is required to get back to C. And we have kind of established this in one of the previous questions, that any change in track that you need will demand a change in heading, or else the wind should change, which is definitely not under our control. Therefore, what we can say is, if I want to change my track by 10 degrees to right, I need to change my heading by 10 degrees to right. All right, perfect. We have seen that before in one of the questions. Perfect. So by asking you to find out the heading alteration that is required. We are trying to actually find out the track alteration, right? And that is going to be exactly same as the heading alteration, which means you don't necessarily have to think about the heading of the aircraft at all in this question. You can assume one if you wish to, but that is not really required. Perfect. Well, this is the track made good, current track made good at point B, and this is the required track. And you're asked to find out the heading change, which is nothing but the track change. Perfect. Let's find that out. Okay. Now think about it. If I kind of draw a line that is parallel to my original track, which means I'm looking at this as my original track, and I've kind of drawn a line that is parallel to my original track, right? And if I can, and let me put two different angles here, angle 1 and angle 2. All right, so let's remove the confusion here straight. We have 1 and 2 already. Angle A and angle B. And if we can find out angle A and B, add them up, and that's the answer. That's the track change, which means that's also the heading change. Let's come back to the initial point here. We can see we are tracking from A all the way. We are tracking up to this point where we intersect or re-intersect the planned track, and then we again drift off exactly to the opposite direction, right? Now, do you think, would you be able to find out this particular angle for me? If you can find that, then that is exactly same as this particular angle here. And therefore, that's exactly same as this particular angle here, which means we are trying to find out angle A all the way here. It makes sense, right? Now, apply 160 and find this particular angle, which you can call as track error if you wish to, but it's exactly track error, or it can be also the closing angle as well. To find that, you need distance off and distance gone, right? Think about it. The distance off is 5 nautical miles, which is straight here. But what is distance gone? Distance gone is only up till this particular point right here. The 70 nautical miles, remember what is given in this particular question is not this distance. It is the entire distance up to the point 2. Now this is where people really get stuck and they have no idea how to find this particular bit over here, if you can see it. And therefore, because if you know that bit, then you can subtract that from 70 and you can find out the distance gone or distance to go by the aircraft. All right, so we have a little bit trick around it. So again, if you think that you have got some idea, pause the video at any point of time and try to figure it out yourself, because that's going to stay longer in your brain. So what I'm going to do now is I'm going to dissect this particular triangle which I have here, right? Let's see what I'm going to do, because the moment I start doing it and after a couple of steps ahead, you're going to get it, the whole thing, and you're going to just go do it yourself. It's that simple. All right, so let me kind of draw a line. I'm kind of drawing it parallel to my planned track, which is right here, and then I'm kind of extending this line down here, right? Now, do you realize that I have created a bigger triangle here just by doing that? Right? And it is also pretty easier if I tell you that this side is going to be 70 nautical miles, because it's like parallel and equal to it, right? And what about this whole side? So this is like 3 nautical miles, and this side over here is exactly parallel and equal to 5 nautical miles side offside over here. So it's 5 nautical miles. Now you can see a triangle where I have 70 nautical miles on one side and 8 nautical miles, which is 5 plus 3 on the other side, right? Now think about it. Now you must have, at least many of you must have got what I'm trying to, where I'm trying to reach. All right, so here I'm trying to find out this angle, because if I find out this angle, that's exactly going to be the same angle A, because if I take this as a transversal now, these two are two parallel lines cut by a transversal. These are more like the interior opposite angles, and they're equal. Right? So in this particular triangle, now I don't have to tell you this because you know how to find out this particular angle A, which you can take as the track error or closing angle, whatever you want. Having one of the side as 70, other side as 8 nautical miles. It's quite easy how to find it. Let's do that. So applying 160 here, it is distance off by distance gone into 60. And the distance off is 8 nautical miles. Track through diagram, distance gone or to go is 70 nautical miles into 60. Perfect. That's going to be 6.8. I'll kind of round it off to 7 degrees. So this particular angle right here is 7 degrees. That makes this angle 7 degrees, and therefore this angle is 7 degrees, and hence this particular angle is 7 degree. That's it. Now you exactly know what to do. You need to find out angle B. Now finding angle B is kind of a piece of cake for you, because you can actually take up this particular triangle here, if you can follow me through, and this angle B is nothing but the closing angle B over here, and you have the distance off as 3 nautical miles and distance to go as 40 nautical miles. So let's find out by applying 160 the closing angle Bravo, which is again distance off divided by distance to go into 60. So distance off is 3 nautical miles, distance to go is 40 nautical miles into 60, and that's going to give you approximately 5 degrees. So B is 5 degrees, A is 7 degrees, therefore you can pretty much understand that the total track change in track, and therefore the total heading change or heading alteration that is required to track towards the final destination Charlie is A plus B, which is 7 plus 5, and that is 12 degrees. Now it is also important to understand the direction of the change, because that can take you off or closer to the destination as well. So since it's pretty obvious from the figure that you need to make a turn or a change to the right to get to destination, your alternation of heading required is 12 degrees right to track to destination. So I'm pretty sure that by the time I drew this extra triangle over here, you must have kind of picked up what to do eventually. All right, so it's quite easy, right? It's not very difficult. Only thing is, when you see the figure for the first time, and if you're not very used to seeing figures for 1 in 60 questions, you must have seen statements. You might get a bit confused. This is how you kind of interpret the figure and make your way through. Okay, so if you're pretty much happy with this particular question, let me give you another one. This is pretty much simpler than the other one, especially having the fact that you got the idea about how to look into the figure. And again, you can see in the figure, this is the planned track of the aircraft, and the aircraft is flying from point A all the way to point B. You have to find out the heading alteration required at point B to track directly towards C. Let's look at a different question, again a diagram based question. As I said, it's not a huge exam friendly question if you're trying to write exam in our country right here, but it's quite interesting, right? It's definitely from an understanding point of view. You'll take your time working out your brains out. So let me give you a different question on this. Again, diagram based, but a little bit more squeezy. I'll just put up the question and see if you can find out.